Hello again, and in this video tutorial I'm going to be covering some of the data definition language SQL commands covered in this chapter, reviewing some terminology, concepts, and skills. So this will serve as your lab exercise, and so please follow along. When you're done, you should have a group of SQL commands to solve the various exercises we're going to be reviewing, and you'll submit that in the appropriate document linked in the lab instructions. I'll also be providing you with the database that we'll be using. It will be the ConstructCo database, but I have saved this database out as a version 2007 or later access to give us full functionality of the database. Oh, I guess I can bring the database window up to show you that. So if you do not use the database that's linked in the lab instructions, hopefully you'll get this message via the video saying go do that, or at a minimum save the database that you might have gotten from some other means out as a 2007 version to make sure that everything's going to work the way it's supposed to. I've learned this the hard way when working with the textbook files. They're in a very old version of Access. So let's take care of that. All right, so we're going to start out with a series of, almost all the exercises we're going to do are going to be related to this ConstructCo database, with the exception of just one that I'll review later. And our first exercise, let's get into it, is you're going to write the SQL commands that are going to be necessary to create a table called EMP_1. It's going to be a subset of the full employee table that's already in the database. I think just one attribute is left off. We want the employee number to be the primary key. We want job code to be the foreign key. We want to enforce referential integrity. We don't want to allow nulls in the employee last name or first name attributes. We're given a list of what the data types should be for these various attributes. So let's get into it. Following what we saw in the textbook, to start a table creation, it's the create keyword and table and the name of our table, and then we can follow that with an open parentheses to start our attribute list. Clean to drop down to the next line, and we'll start typing these away. And I'll do just the first line here. This is going to be a char 3, and we want this to be a primary key. Right? So it was defined to be a char 3, so we've listed it. That means it's a fixed length of 3 characters for this employee num, and we wanted it to be the primary key. So at the end of that line, we put a comma, and we drop down to the next line. See if you create the remaining attributes, and then let's come back and compare notes before you jump into the foreign key. All right, so check back with you. Okay, so did you remember your not null constraints for last name and first name? All right, and remember your commas at the end. And we're ready now to do the last bit, which is to define the foreign key for this table. Remember that the foreign key is listed to be the job code. So foreign keys will start out with just that word, foreign key, and then you put the name of the attribute that is going to be the foreign key. Now you want to use the references keyword to specify the other table that this attribute also lives in. So references, the other table is job, and it has the same attribute name. Put the parentheses there. Now remember that we also need to have a closing parentheses to match up with our opening parentheses. And this is the end of our SQL command, so we put the semicolon there to signify that. Now that we have that completed, we'll take that code that I've typed in. We'll come over to our construct co database and access. I started by creating a query here. Let me get rid of it so that you can see fully, right? Our query design, we don't care about tables. We come over to the SQL button, and that gets us our kind of our code window here that we can execute these SQL commands in. So I just going to copy and paste the code that we typed in there. You might continue through the rest of this lesson just to type the various commands into this query window for us. And once we've got that typed in, just hit the run button, and there's employee underscore one now created. If we were to double click on it, we'd see the attributes that we created. No data yet, that's to come, but if we go to the design view, you'll notice that these SQL standard data types have been converted into what Access likes to work with. So that's nice and convenient for us. And we notice that the primary key icon is listed for employee num. So awesome sauce. All right, let's go on to the next exercise. So now that we've created the table structure from the previous problem, we're going to be manually, or through SQL commands, we're going to enter in the first two records of data into this table. So we're going to use the insert command to do that. So I'll do the first one here. Insert, and the syntax is into. Then you name your table. Then you follow that with values, parentheses, and now you start typing in the actual data. Since all of this data is character-based, even including the date for the time being, we have to use apostrophes around the data to denote it as such. So we go through the list here. The initial, then comes the date, and follow that with the closing parentheses and terminate the SQL command. Okay, so now what we'll do is you'll write the second one and we'll compare notes. Second record. All right, the second SQL command for the second record would look something like that. And two things I changed in the time that it took me to write that second one. The first is that I've switched back over to Notepad. Learned that lesson the hard way in the past, where if you copy text out of a Word document and paste it into Access, you could end up with a lot of syntax errors because there are codes that are behind the text that we type in Word that get carried over behind the scenes and kind of corrupt the database engine. So best to work in Notepad or straight away in Access in the query window. But I'm now going to switch over to typing everything into the Notepad. The other thing was that I realized that, well, kind of old habits had gotten a hold of me, and I typed in the date a certain way. And even though the information was presented in a different kind of format, that is namely day, month, and year, so I've switched my date format in here to that day, month, and year scenario. So just to be a little bit more consistent. Now, when testing these, don't copy them both in to your query if you're doing it that way, or don't write both insert commands into the query at the same time. You only have to execute one at a time. So we're going to do the first one first, and we get a little confirmation we're about to append a row. We say yes to that. Then we will take the second one here and do that one next. And yes for that. And then if we inspect employee 1, we see our 2 records now being displayed for us. Okay, our next exercise is to fill out the remaining part of our imp_1 table. We're going to do another insert command, but this time we're going to use a select clause on it as what we want to do instead of manually having to do the remaining 6 records. We're going to go into the employee table for our existing table here in our database, and we are just going to pick employee numbers 103 through 109 to complete our imp1 filling out of records, all right? Because that's what it shows here, that we want imp1 to be 101 through 109. So rather than having to do those individually, we'll use a cool little feature to make that happen. We remember that we only want certain attributes, not all of the attributes. So we have to be careful when doing that, but the basic structure is an insert, just like before, and you have to specify into and what table you want, right? But now, instead of values, we're going to do a select clause. And let's see if you can finish out the select clause. What other attributes do we want from the employee table that would be consistent with the attributes that we've already set up for imp_1? Let's go off and compare notes when we come back. Okay, so we only need imp num, imp last name, first name, initial, hire date, and job code, and we're selecting it from the employee table, right? Now, we don't want all of those records, right? We just want the records where the employee number is between 103 and 109, right? So we can use our between relationship or special operator to be able to specify. So what clause do I want here? What does our conditional clause start with? Where? And what attribute are we going to be imposing this restriction on? Imp number. And then the special operator is between, and here's where you got to be careful. What is the data type for the imp number attribute? It is not numeric. We set it up to be a char field, a character field. So you've got to enclose that in single quotes to make that happen. If you just put 103 and 109, you will get an error. So syntax. Don't forget your semicolon. Syntax. Remember the programming days, right? So those of you that have had programming, you're going to be familiar with this, with these syntax issues there. Okay, so we can go plug this into our database. Query window. Boom. And run. And we're about to append 7 rows. You bet I want to do it. So there it is. And if I inspect imp_1, now all of those records appear. Good going. Let's get ready for the next one. Our next exercise involves modifying some data in our imp_1 table. When we do modifying of data in a table, we use the update command to do that. So we want to change some data associated with employee number 107. So we start out with our update keyword. We tell it the table name that we're going to be updating. I'll drop down to another line. We now specify the attribute that we want to change. It's job code, so it's the set keyword, job code, and we tell it the new value we want it to have. We want it to have a value of 501, and we have a condition. The condition is going to be like a condition in a select statement. That's going to involve the where keyword and the attribute that we're going to base the condition on, and what the condition is, end it with a semicolon. All right, so we'll take that data, or those commands, SQL commands, we'll go into our database. Let's take a peek at our table here. For 107, we see the job code is 500, and we want to change it to 501. Okay, very good. So we'll paste that in there, and we'll update that. And we're about to update one row, and boom, that's done. Take a look at it again. 107 now has been updated to job code 501. Good job. Let's get ready for the next one. Okay, in this one, we're going to be deleting a row from the table. So we use our delete keyword SQL command to do that. But notice we've got several conditions that apply here. We want to delete the row for an employee with the name of William Smithfield, hired on June 22nd, 2004. Job code is 500. And we are instructed to use logical operators to include all of the information given in this problem. That is, don't just write a SQL command to delete the record based upon just the first name alone, or the last name alone, or even just the first and last name. We want to include all of this data, all of these conditions. So we'll have multiple conditions that are going to apply here. There's lots of good stuff to learn from this one here. We start our command with the delete. We follow it with from and then the table name that we want. Now we follow this with our where keyword, and now starts the condition list. So we will start with a last name, let's say. So EMP LName equals Smithfield, and we got to be careful about caps. Good idea to be careful about capitalization, right? Now, that's not the only condition that we want. We also want first name and we want hire date. So that's where the logical operators. So what's the appropriate logical operator here? And then PF name equals, we follow that with another and. Now, here's where it gets interesting. When we were inserting data into the table and we had a date value to insert, we used character delimiters, namely the apostrophes or single quotes around it. But whenever you are going to be doing a comparison or a calculation on a date field, you have to enclose it in # delimiters. And this is an access only thing. So since we're working in access, you're not going to put the single quotes. You're going to use a $, and then you're going to put the date that you are interested in. And then the # symbol again. All right. So that's what that looks like. One more condition to add, right? It was the job code 500, right? And job underscore code equals, and this is a char field, remember, so it's got to be in the single quotes as well. So there's our command to be able to delete that record. So let's go ahead and copy that off and paste it in our query. Let's go ahead and take a look at our employee. This is Smithfield. So there is Smithfield. So when we're done with this, they should be gone. Well, sorry, William. Guess you just didn't make the grade on that one. And away we go. We're about to delete one row in the specified table. And we'll click yes, and we'll double check. And William is now gone. Well, you know, he found a better job someplace, so good on him. So anyway, that is our exercise involving multiple conditions, logical operators, date delimiters, lots of good stuff there. Let's get ready for the next one. The next exercise is an interesting one. We're going to create another table as a copy of our EMP1. And it's a handy little tool to have. I've used it in the past to do some testing without basically working on the production table. There may be that you're going to spin off a version of a table and you want to start from a baseline and save yourself a bunch of work, and there's just a few tweaks you want to do. Lots of different case studies for this one here. So we're going to use the select command to do this. You may or may not find this in the textbook, but we want to select everything and into from bada bing, bada boom, just like that. Right? So it's basic like an insert into command, but we use the select clause instead to do that. So we can take that and pop that into there and run that sucker off. And there's our employee 2 table created with it fully populated. So nice, quick and dirty way to create another table from an existing one. All right, we'll get ready for the next one. Okay, now that we have our imp_2 table, we're going to play around with that one for a little bit. And we're being asked to add a couple of new attributes, the imp PCT and proj_num to that table. So we're not altering data to an existing table, we're altering table structure. So we will use the alter keyword to do this. We're given what the data types are for these two attributes, a number since we're working in access, and a char3 for the proj_num. So our command will be the alter command. It's followed by the keyword table, followed by the actual table name. Right. And then we use the add clause to this and start to list the attributes that we want. PCT, that is going to be a number, comma, right, because we have multiple attributes that we're adding here, and then proj_num, that's going to be a char3 end the SQL command. All right, I've put that into my query window here, and I am ready to execute that. And no feedback on this one. Notice we're not creating a table, adding a record, deleting a record, adding just those two attributes. We don't get any kickback or feedback on that. If we double click on the table, we'll see that the two attributes have been added to the table. So That worked well for us. Good. Let's go off and get ready for the next one. Okay, in this one, we're going to be updating one of our records for employee number 103 and assigning an employee percentage value of 3.85. So that is updating table rows. So that is our update keyword, the table name. We then follow that with a set keyword. We give the attribute name that we want. And we have to have a conditional clause so it knows which record we're interested in. Now remember, employee num is a character field. That one might mess you up a few times. So terminate your SQL command. We'll take that, pop that into our query, give that a run. All right, no syntax errors. We're going to update row. We'll take a look at 103. Employee 103 now has the employee percentage there. So good work on that. Let's get ready for the next one. Okay, in this exercise, we're going to be doing a similar update command, but this time we have several records we want to affect. So we can't just use where employee number equals. We have to come up with another way to handle what if there are several values that we want matched. So if you go back to your SQL chapter and look at those special operators, you'll see that there is one called the in operator, and we'll take use of that. We'll make use of that. So why don't you go put me on pause if you haven't been doing that and see if you can figure this one out, and let's come back and compare notes. Okay, so just like in our previous exercise, we've got our update, we've got our table name, we've got the attribute that we want to affect, and then we've got our condition. The in special operator is defined by using parentheses and then putting the values separated by commas within those parentheses. And since, again, employee number is character-based, they've all got to be in closed within single quotes. And we'll pop that dude in. Oh, if I type the right keyboard command, knucklehead. And there we go. You're about to update 3 rows. That sounds good to me. Let's take a look at that. So for employees 101, 105, 107 all got the 5% values in their attributes. So good work with that. Let's get ready for the next one. Okay, so now what's going to happen is for the remaining records that don't have a value in the employee percent attribute, we're going to assign a value of 10. Now, not having a value, no value, not a 0, right? But no value. That's another special operator from the SQL chapter. So see if you can go off and find what that special operator is, and it should, our update command should be very similar to the previous one. Let's come back and compare notes. Okay, so what changes is instead of the in special operator, we use the is null special operator. That means employee percent has nothing in its fields for a value. So hopefully you found that and got that right. We're going to plug that in and run it. And we're going to update 4 rows and see that we now have values of 10 wherever they were empty before. So good on you for getting that one. Let's move on to the next one. All right, in this exercise, we're going to do a little field math. A little field arithmetic as part of our update command. So we want to add 0.15 to the employee percentage field for an employee whose name is Maria D. Alonso. I'm going to ask you to use logical operators so that we can base the condition on all parts of the employee name, not just the first or the last. All right, so we're going to start out with our update command again. The table that we want to manipulate, the field that we want to affect, and this is where our math's going to come in. We want to add 0.15. Again, programming comes in real handy here again, right? Because we're very familiar with how to do update commands. Take the previous value of what's in the employee percentage field, add 0.15 to it, and that becomes the new value in the employee percentage field. All right. Now comes the where clause, and put me on hold and see if you can complete this using your logical operators. Okay. Did you get your ands in there? And did you remember your semicolon at the end? And that's all there is to that. That's not too tough. We're going to take that, pop it into our query window, and hit run. We're going to update a row. She got an extra 0.15 added to her employee percentage. Okay, let's get ready for the next one. All right, let's work with another relational operator in this exercise. We want to set the project number to 25 for all employees whose job classification code is 502 or higher. 502 qualifies, as well as 503, 504, so on and so forth, right? 502 or higher. So another update command. Let's see if you can write this one, and let's compare notes. Okay, so our where clause is going to be using the greater than or equals to, and then 502 for our number. Pop that in, run that, updating 2 rows for 502. So it looks like the first record got project number 25, and this record got project number 25. Good. Let's get ready for the next one. So this one, we're going to change project number to 14 for employees who were hired before January 1, 1994, and job code is at least. So at least is another way of saying or 501 or higher. So let's go off and write that one. Remember, you're dealing with the date here, so because it's access, you're going to have to put the date pound delimiters on either side because we are doing a comparison here, right? So let's come back and compare notes. So here's our syntax for that. Less than, that is before January 1, 1994 with our pound delimiters on either side. We've got the AND logical operator to do an at least 501 as well in that. So hopefully you got that. And now employee 2, anybody before 1994, so this one right here, project number 14, 1994. This one, 14, 94, 14, before 94, 14, boom, 14, and not for the last two. So hopefully you got those. Okay, we are ready to move on to the last exercise. Yippee! Okay, for the last exercise, I've got a doozy for you. We're going to be switching databases now to the simple code database that was linked in your lab instructions, and give you an opportunity to experience what a trigger is. Now, triggers are very useful items. They basically are a way to store commands within the database that are triggered to execute upon certain events. And again, if I can go back to the programming context, there's a lot of similarities between what we do in this database class and what we've done in programming. And here's another one. And think about those of you that took CIS 12 with me, event-driven code. So when the mouse is clicked, when a value is changed. Well, in the database world, triggers can be based upon when you insert a new record, when you delete a record, when you're going to alter a field value, things of that nature. You can have code, SQL code, automatically execute to help you in maintaining your tables and automating a lot of what needs to happen. So in this particular situation, what's going to happen is we've got this database that's got two tables in it, customer and invoice. And as we can see in the table structure here, we've got the customer table has got a number, a name, and a balance. So, you know, this might be kind of like commercial customers that rack up a balance over time as they're ordering parts, and at the end of the month, they get a bill. Then we have an invoice table, and it also includes the customer number attribute as a foreign key in it. And we have an invoice date and an invoice amount. So as a customer comes in, they buy more things, or over the phone, they buy more things. An invoice is written up, gets an invoice number, the customer number gets recorded, and the invoice amount for that particular invoice is recorded. Now, wouldn't it be cool if when that happens, when a new record is inserted in the invoice table, when an invoice amount, the customer's balance in the customer table automatically updates for that new invoice amount, and that's where a trigger comes in, and that's what we're going to build. Now, this again, if you're dealing with an enterprise level relational database management system, Oracle, MySQL, SQL Server, they all have SQL commands that are directly related to triggers, and you read about them in the chapter. Access handles it a little differently, but it does have a mechanism for you to be able to basically create triggers, and I wanted to walk you through that process on how that happens. So I've brought up our simple access database here with our two tables, just like you saw in the image there in the figure. And again, I have to warn you that you need to make sure you're using my database. What I'm about to do will not work if the database is in an older version. All right. It needs to be in a more recent version of Access. Number two, what I'm about to do may not work if the database is not in a trust environment. Now, sometimes when you open up databases, you get the little yellow alert bar kind of in the middle here saying, are you sure you want to trust this? And you get the ability to enable content. Usually that's all you have to do for that database to be trusted. If you end up where you're not able to see the table events that I'm about to demonstrate, you can go into File and go into Options and go into the Trust Center here and go to Trust Center Settings. And typically all you have to do is go to Trusted Locations and add the location where the database is that you're working on, and that's usually good enough. So we'll assume that that is the case. And what we want to do is I want you to double click on the invoice table to bring that table up. Remember, this is the one we want to trigger off of. When a record is inserted here for a specific invoice, we want to trigger off of that and then update the customer table. So when you have brought up the invoice table, you'll see some context-sensitive menus up here, tabs up here, and you'll click on the table one, and you should see all of these events that are enabled. And what we want to do is we want to use an after insert event. So, right? So this is the trigger mechanism that we are using, much the same way that mouse on click was the trigger mechanism we used for a lot of the stuff that we did in CIS 12. So we'll double click on that to open up a new after insert window. And what we do is we tell it what it is, what action we're looking to do. And we're going to start by having it look up a record. We want it to look up a record in customer. So I start to type CU, and you can see it automatically recognizes table names that are associated here. So that's good. And my where condition is going to be the customer table, and then I'm going to put a period, and then customer num equal to invoice table dot customer num, right? So basically, after the record in invoice has been inserted, I want you to go to the customer table and find me the correlating record in customer where the customer number from the invoice that we just entered that triggered this is equal to the customer number in the customer table, right? So that's what part of that's going to look like. Now what we're going to do is we are going to edit the record in this customer table. And that's going to be the action that we're going to create here. We're going to come down here, we're going to say edit record. All right. And then under the edit record, the very first thing we have to do is we've got to set up a local variable to hold what the current customer balance is in that customer table. So we'll come in here and we'll do a set local variable. And we'll call that local variable temp. Let me get out of my all caps. And my expression is going to be, we want that variable to hold the customer table dot customer balance. So whatever balance was in the customer record at the time of this trigger, stuff that into temp for the time being. Now we're going to add a new action here. And in this action, we are going to use a set field action. And what we want to do is, field that we want is our customer customer balance. That's our field that we want, right? That's the one we want to update. And the value is going to be our temp variable plus the invoice dot invoice amount, right? So that says that take the invoice amount, add it to temp. Temp represented the previous customer balance. So now that is the new customer balance, and that's what's going to overwrite what was previously there. So now it's important that we go off and save that trigger, and then we close that. And now we're going to test this. And I've given you the record information for customer 1001. We're gonna add a new invoice record, and it's going to have this data in it. All right, so we're going to type that in. The invoice number is 8005. The customer number is 1001. Be careful with the existing values that are in those numeric fields. Make sure you get rid of them completely. Don't leave them lingering. It'll screw up your trigger. And the amount, and this is a notorious one right here that you got to make sure you get rid of completely. 40. Now, we haven't finished adding this yet, so the trigger hasn't fired, but the minute I click off this, I have completed my record, and I'm ready to then go into the customer and see if it updated what was previously there. If I open up customer, we'll see that customer number 1001 had a previous balance of 840.92. After we're done adding 225.40, we should be 1,066.32 to that. So click outside. That completed the record entry. You notice the little edit icon went away. Now if I bring up my customer table, there we go. Customer balance has been updated to 1,066.32. So isn't that cool? So anyway, take a screenshot of your after insert table event that you created. Take a screenshot of that, submit that to me in the lab instructions. So I hope you found that informative, and I hope you find it helpful for the upcoming assignment. Thanks for watching.